हेलो। तो आज हम स्टार्ट कर रहे हैं अपना डे 2 ऑफ लर्निंग रस्ट यूजिंग चैट जीपीटी एंड अदर एलएलएम मॉडल्स। सो यहाँ पे मैंने अपना डे 2 का प्रॉम्प्ट डाल दिया है। नाउ वी शुड प्रोसीड। सो saying good, we'll proceed correctly. I will not drift. Today we'll strengthen the mental model. So now quick revision of day 1. What I actually learned on day 1. Core foundations. Answer material as you read. So you can answer it too if you know that. Otherwise follow my day 1 video. First one is ownership. So ownership has every value has exactly one owner. When owner goes out of scope, value is dropped and more semantic transfers ownership. Move semantic transfers the ownership. Whereas the type that implement copy are duplicated instead of moved. So again, ownership, we had studied about ownership in sort of pointers in hash memory. There is a pointer. Uh, who's the owner of that pointer? Who is responsible for freeing that pointer? So that's ownership. So every value has exactly one owner in Rust. And when one owner goes out of scope, when the owner goes out of scope somehow, the value is dropped or the pointer becomes invalid. And third point is like move semantic. There is a thing called copy and there is thing called move. So move semantic is used to transfer the ownership. Like the ownership was with variable, let's say s. We want to move that ownership to, let's say, variable p. Then moving that ownership to variable p, s will become invalid automatically. So move semantic transfers the ownership, and there can be only one owners. So P becomes the owner and S becomes invalid. And the last point here is that types that implement copy are duplicated instead of moved. So copy is used in integers like I32 and stuff like that, which can be duplicated very easily. So they are duplicated in the memory, and that's why they are copied instead of you know changing owners to owners. Whereas move is used in cases of strings, vectors, which are sort of stored in a way of pointers. So move is used in that term, in that case. Whereas copy in cases like we are storing a number in a variable, copy is used to duplicate. Let's say there is a variable s, and we want to you know assign that variable s the value of uh, variable s to a variable, let's say y. What we'll do is we'll say let s is equals to, let's say, 5 is equals to 5, and in another line we'll say let y is equals to s. And here what happened was s was duplicated and y was assigned the value that s had by duplicating that value. And move is something like we are trying to move a string, let's say hello. Then what we'll do is either we can take the reference of it to use it, mutable or immutable. But if we want to transfer the ownership, we can do that. But in that case, the string 1 will become, let's say, invalid, and string 2 will get the pointer because there can be only one owner. So that's all about ownership in Rust. Why? Why is that ownership such a very important concept in Rust? Because it guarantees something like no double free. There will be no double free call for the same pointer. So let's say S had the same pointer, S1 had the same pointer, S2 also was pointing towards the same pointer. So if we try to free S1 and after that we try to free S2, S2 will become invalid because S1 has already freed that pointer. So there can be no double free because it causes unexpected behaviors from our program. It may be exploited very well. Uh, the second point is no dangling pointers. There can be no pointers just left there becoming valid and their variables just moved out without freeing them. And the third is that though no data race. Data race in cases like we are writing a change to the pointer, and not only we, as in there are multiple players or multiple functions that are writing uh, data to the same, let's say, pointer. In that case, data race becomes unavoidable. But we should avoid as much as data race as possible, because it makes some very bad conflicts in our code that can uh, create problems and exploit. Now, second thing that I learned yesterday was borrowing. So borrowing is like we are taking a reference from that. We are not just moving the value. We are just taking the reference of that. We know there exists a value, and we are taking a reference of it. We are not moving the ownership. And so let's say there is a variable s1 which has a let's say string hello, and we want to make that string, let's say, hello world. We'll take a mutable t, let's say. uh, we'll take a mutable reference of that, and we can add hello world to it, add a string like push. Stir is a function that can use to push the string, uh, and we can do that. We can make hello world. But after doing all that changes, where we are making a new data, after doing all that, we have to free it using the same owner. Like s1 will free it, no other variable will free it. That's ownership. And borrowing something like owner will not change, but you can use the data. Again, one rule here was important that there can be many immutables. Like you can take the data in read format, you can read it, do stuff with that, but you cannot write that data back again multiple times. Many mutable are not accepted in Rust. Only many immutable, like no changes will be made. Then only you can take many times. If there are like multiple changes you want to make using different functions, then there can be cases of data erasures and all that. So you can't do that because Rust becomes risky. But Rust is there because it is risk free most of the times. So only one mutable, never both simultaneously. Like you cannot take immutable and mutable at the same time, because mutable is trying to read the data and sorry, immutable is trying to read that data and mutable is trying to write it. So there becomes again a data race and multiple other problems. Why is to enforce aliasing using XOR mutation at compile time. That's a more compilation thing. Now stack versus heap. So I also studied about stack versus heap. Stack is something that is of fixed size. At compile time it is known, but at runtime it is not. Whereas heap is dynamic size, and at runtime it is allocated. Like when the programming is running, heap is allocated. As for stack, when the program is compiling, stack is allocated. And stack is a fixed size. We write it in a fixed size in a program. It's only known till the compile time. After that, heap becomes the memory. So string owns heap memory. We store string. What is a string? String is multiple characters placed consecutively. Like let's say I want to say hello as a string. So we will take the word edge, the first character edge, and we'll take that pointer, the memory of that heap memory, and store it in a variable. And what we'll do that after that is, after that we'll consecutive like we'll just beside it, we'll just store all the others, characters like h ke baad e l l o, and then null character like backslash 0. So that signifies that string has been finished. You have read your string. So that's how strings being stored. As we have read in C, we have studied in C. So yeah, as for the pointer, this is pointing towards stir, is a borrowed slice. So borrowing from here, you can borrow it. Now move versus copy. I32 can be copied because it is easy to duplicate, and you can do that. So, whereas string, you have to move the pointer to it. For a vector, you again have to move the pointer to if you want to. move the pointer to another variable. As for ampersand t, what is this? Copy pointer, copy, pointer copied, not data. Ah, so ampersand t, which is taking a reference, copies the like pointer is copied, not data in ampersand t. And now we escalate to day two. Now, what I'll do is I'll be asking my doubts, which are very silly. I don't know, very advanced. I don't know what is my level right now. So I will try to learn as well as ask it some questions, and it will also ask me questions. I'll try answering it. Do not focus on my spelling because I'll be writing very poor English right now with many spelling mistakes. So let's focus on day two. Concept one is control flow in Rust from first principle, like from basics. So before we write code, you must understand why Rust treats control flow differently from other languages like Python or C++. The core principle everything is an expression. In Rust, uh, most constructs return values. If returns a value, match returns a value, loop can return a value. So all these things, if, match, and loop can return a value. So in Rust, most most constructs, what is this? Most constructs return a value. This is not syntactic sugar. This is type-driven design. Let's try to understand what's trying to say. In Rust, most constructs return value. Like if returns a value, match returns a value, loop can return a value. All right. So it's saying that this is not a syntactic sugar. This is type-driven design. I don't know what that means, but it'll try to explain it. So if expression in Python is written as x is equals to 5 if condition else 3. All right, this is the shortest form to write in Python. In Rust, it is written as let x is equals to, okay, what is this? Let x is equals to, I've never seen this. Let x is equals to if, then condition 5, else 3. So it's same thing, but a very different syntax. Now it's telling me to notice no semicolon at the end of the branch. Okay, it is there. In Python, there is no semicolon. There is no concept of semicolon in Python. It's very, space driven formatting. Whereas in Rust and C++, there is semicolon. Java. What is telling me to notice is no semicolon at end of the branch. What is the end of the branch? This. So there is semicolon, there is not because this is Python. Both branches must return same type. Both branches must return same type. Entire if evaluates to that type. Entire if evaluates to that type. It's telling me why no semicolon. Because semicolon turns expression into return value. Yeah, this is something. It's in Rust. Like you make a function, it will automatically return this bracket. Uh, and if you add the semicolon to it, it will make expression or statement. So semicolon turns expression, that is this expression, into statements. There is semicolon. What is trying to say? Final expression without semicolon becomes return value. Yeah, that's understood yesterday only. So if there is anything and in a curly braces, and if there is a last function or last expression, it automatically, without a semicolon, it automatically becomes the return value. So here the x is returned as 5, the x is equals to 5. But if there is semicolon, it becomes a statement, not a return value. So you have to return 5 then semicolon, then it might return x is equals to 5 again. But right now after semicolon and not mentioning that it is a return, it becomes x is equals to sort of void. This can be compared to void as in C, and void, there is no value to it. So x becomes this. Now loop variant. Rust has three main loops. So infinite by default. So Rust has three main loops. Loop, while, for. So loop is something that's infinite by default. Must be break and can return value using break value. Okay. And whereas while is condition based, similar to C or Python. All right. As for it's iterator based, most idiomatic, and prevents off by one error. Let's see that. Range syntax is 1 to 5, then there is 1, 2, 3, 4. If there is 1 is equals to 5, then it will go till 5. Okay. Why Rust prefers for? So because it enforces iterator abstraction. So you avoid manual index mutation, infinite loop bugs, and accidental mutation errors. So again, why Rust prefers for? Because it enforces iterator abstraction. That is, iterator, I guess, is the count. Let's say you create a iterator a variable I, let's say, and on that I you will make a loop by doing I plus plus or I minus minus conditions if it meets them. That's what for loop does. So it says you avoid manual index mutation, infinite loop bugs, and accidental mutation errors. Uh, we can avoid manual index mutation. I've never seen the for loop in Rust, but it is telling me that by using for loop, I can avoid manual index mutation, infinite loop bugs. Manual index mutation is something that you try to do manually. So it is assuming that man can do errors. So yeah, manual index. Infinite loop bugs. What is this? In while loop, there are sometimes we forget to uh, append the value after the loop goes one cycle. So it gets stuck at the same value and just starts a forever loop. That happened mostly in C. And accidental mutation errors. So there can be accidental mutation errors. So it stops that. Ownership inside loop. So let's say this is a loop for X in vector, whatever. The important concept is this moves vector, but for X in ampersand vector, this is taking a reference, which is immutable. Yeah. If it was mutable, it would have mentioned MUT after ampersand. So this is taking just a reference, and on that reference, we are making a for loop. So this borrows, yeah, taking the reference. This borrows the vector, whereas this one directly moves the vector. So earlier, let's say if there was a variable called L is equals to vector or V is equals to vector, that would have become invalid after running this loop. But after running this loop, that would have become invalid because this borrows it. And after borrowing it, if we want to free the pointer vector, we can do what? If it was stored in a, let's say, variable v, we will just free using the v. We will not free using this x. What it's doing is for x in reference of pointer vector. This borrows. You must understand this distinction. I'm trying to understand it. I'm a beginner. Let's see. Now there is test section. So it's telling me not to skip it. I would tell you to not skip it. Try answering them. I'll answer here also. Conceptual understanding. No, conceptual questions. So first one is why must both branches of an if expression return the same type? What is this question? Why must both branches of an if expression? When does if expression has two branches? Let's ask it. what are two branches in if it's the expression? As for returning the same type, uh, what I can guess, I guess it returns same type. It returns same type as this void, similar to this void by default. I don't know if this was talking about this one. Let's see two, what I can understand from this question. Why does adding a semicolon to the last line of Acha, what does adding a semicolon to the last line of the block do? I know this answer because adding the colon at the end of the block be makes the value, let's say return value a statement, and then it returns this. And now let's ask, can we compare this to the void in C? Because that's what I wanted to ask. If because in C it automatically I guess returns zero every time. Every time it returns zero if you did not mention to return something uh, syntactically, or it returns the type that you made the function to be. Like let's say I made a function called int and then I defined that function. So it will return definitely a zero. But if I make a function void, it will not return anything. But here it returns this, bracket. I don't know if it is comparable to void in C. Now the third question is asking me, why is for loop safer than while? So we have studied here only three reasons. We want to recall it. For loop is considered safer than considered safer than mm, while loop because of what unexpected mutation of value um, ITERA with greater error due to manual handling and what? That's it, I guess. I can't remember much more. Now, what's fourth question? When would you prefer loop over while? I don't know. When would I prefer loop over while? So, there is again question. Is the loop also a type in loop of Rust? Like you are telling me that there is there is let's say for loop, then while loop, and then loop. Is that what you are telling me? And when would you prefer loop over while? I don't know. Now, code prediction. So it is telling you to predict something. So what does this print? So there is a variable x that has been assigned. Like if true, then 5 is the value that x has, else 10 is the value. But what is the condition? There is no condition in it. Like x true when? Is x true? Is x true by default? Then it would return 5 and tell me what is the condition here. That we are running you on this. I don't see much of a condition. As for print ln, it is just a macro where it prints the value of x. So if x is true by default, then it will have a value of x. So let's say 5, 5. And if it's by default like false, then it would return a value of 10. I don't know if that happens. And then there is another question. What is this? What of this? In the second expression. Oh, in the second expression, since instead of returning something, we made it into a statement. So I guess it will return a void, which in case will not print anything. So will it compile? If yes, what prints? And if not, why? Uh, so I guess this is the problem here. So in SECOND code, I see that we have semicolon after 5. That makes it a statement instead of returning it. So I guess it will not compile. Now another question, ownership prediction. Now we are seeing some ownership prediction questions. So there is a main function, yeah, the starting point, and then there is a variable v. It's immutable, all right? Because if it would have been mutable, then there would have been a mut after this let. So yeah, this is immutable, and there is a vector. This is again a macro, and 1, 2, 3. This is a vector. Now for x in v, so instead of taking the reference of v, we just directly took the v. So what it did was made the v invalid. 6, 6. Instead of taking the ampersand v, we took directly v. That changed the ownership of the vector pointer in the heap memory. That's what it did. After that, what are we trying to do? What is this expression? What it does is, I don't know. Why it does? This is a catch. But this will, what will do is, this will print X. Yeah, it will. But here we are trying to call V, so it will just throw a compiler. And at last, we are trying to print V, so it will throw compilation error, compilation error, whatever. Now implementation task. So it is telling me, this is the last question, I guess. Yeah, it always does that. So it is telling me to make a function called classify numbers that take number as an input. No, takes the I32, which is integer of 4 byte, 32 bits, and return a return static string. What is this? Using if as expression, no early returns. So I don't know. I don't know. Let's do seventh one. Seventh question. Use if as expression, no early return, no semicolon on the final expression, post your answer and implementation. So let's do few things. Since we are here, I'll just name it one.rs. That's what I do. And I will be using, new web to write this code. So yeah. Now let's start by making a function. Sorry, insert mode. Insert mode. Now let's start by making a function called main. Inside that, sorry, my string. This is weird. It's my keyboard doing some weird array. So what we'll try to do here is we'll take a variable. Let's say y. Is it y? Shall we take n? Let's take num is equals to, let's say, number 5. All right. Now what we'll have to do is create a function classify number, which will take the same thing. So we'll create a function called classify number, like that. So yeah, classify number. Classify number. Oh, again, it's behaving weirdly. Classify number which takes n and structure is I32. So it takes n and structure is I32. After that, we get return as this value. So we get a return of, how does it know ampersand, static stir? What is trying to do? Ampersand sta, sorry, static. Yes, yeah. And then we'll have to do some functioning. We are taking a number, which is I32. and we have to return what? Use if as expression, no early return. What we have to implement is write classify number. Classify number. Classify what? Fi what? Positive, negative, or zero. That's what it's suggesting. So let's try writing it. And we can also see something like there's no semicolon here, because whatever the case may be, it will get returned automatically. So there's no need for semicolon, or else it would have needed semicolon. Then we have to specify return. So let's try to do it. If n is less than 0, I don't know if it's semantically correct, then we'll return a string called negative. That's how it should be done. And there is else if. That's what I'm getting suggested. Else if n is not equal to but greater than 0, then we'll try to type, positive. And I don't think I should. Yeah, there's last. Else it's 0. ZVR. All right. And there is no semicolon after this positive, negative, and 0, as it was being suggested. Why? Yeah, because if there would be a semicolon, it would just become an ordinary, statement. We don't want. So now, all right. So we are making another function called classification. Classification, and we are passing this classify numbers to it with the variable num, that is 5. Right? What is it? I'm pressing an end key and that's what it does. I don't know why. It's weird. Semicolon. Now we are just print. Let's just print the classification. Nothing more. Classification. That's what we are trying to print. So I guess this is good enough guess for us, and it was not just our own guess, it was even, Copilot helping us. So, it seems good enough. What we are doing is we are first of all creating a number variable, and then we are creating a classify number function, and we are returning values like which is a static, ampersand static stir. So I've never seen this format, ampersand. I've seen ampersand, mute or then stir, and then I've seen ampersand stir. I've never seen this ampersand static. And what is this? Single quote static stuff. I've never seen this. So let's ask it. But this is our best guess. And what finally I want to do is just, try it compiling it by, Rust C 1.rs. Does it? Yeah, it does compile. Wow. Yeah, 5 is positive. Now let's make it negative of 5. Let's do negative. Just see, negative. Yeah, it does work somehow. What somehow? I got suggestions from the Copilot. That's the learning process, man. We're not just copying it. We are writing it and we know what we are trying to write. So I guess we have cleared this phase one. Before that, answer me this. Before that, answer me this. What is this type? I I've never any never seen it. I've seen new uh, reference reference of mutable, let's say string. I've seen this, and I've seen just string. But this is new. So it will first check our all answers and it will try to answer our doubts. So it is telling me I'm thinking. Now it will try to correct me precisely. Correction is conceptual question. So first question was, what two branches in a expression? So yeah, expression, and then this condition and the return value, else this. Each the curly brackets block is a branch. Your statement, I guess, return same type as by default. Incorrect. It does not default to this. Return whatever the final expression evaluates to. Example, this is true. What will this return? Both branches returns I32. So entire expression is I32. It only becomes this void if you add semicolon to it. So yeah, that's what you did. You added a semicolon. Let me verify it. Yeah, you did add a semicolon here somewhere. Where is this? Yeah, you added a semicolon here. See this? You just added a semicolon. Oh, it's confusing here. Okay, let's try to understand what's saying. So if there is no semicolon, they both are I32, which means they both are integers. So there is no question of returning this void. If you add semicolon or both branches evaluates to this, then only we get this. Now semicolon behavior, your answer adding semicolon at the end of the block makes the return value a statement, then it returns this. This is correct. Now add a semicolon turns expression into statement. Statement evaluates to this is, now this was my doubt again, is this bracket like void in C? Partially, but the difference is C void is absence of type, whereas Rust, this is actually a type with exactly one value. Okay, so void is sort of absence of type. If there is no type, it's void, whereas this bracket is actually a type in Rust with exactly one value. And that value is the bracket itself, I guess. Important is you can store this bracket in a variable. Wow, fascinating enough. Why would I want to store something so useless? So let's say we are creating a variable x. and we can store it, but you cannot store void in C. So Rust is more explicit. And why for is safer? You said unexpected mutation, iterator error due to manual handling. So this is correct direction, but more precise answer would be for uses iterator abstraction. So there is no iterator in for loop. So yeah, no manual index mutation. We are not adding +1 +1 or +2 +2. There is no mutation for the index. Because for making the mutation, what we would actually need is a mutable variable, and Rust tries to default us by not using. It's trying to making us not use immutable variables as much as possible. So therefore, the for becomes sort of no manual index mutation. It prevents one by one. It prevents off by one. Yeah, I guess what I'm guessing from here is sometimes we run a loop on a length of, let's say, array, then it's off by one because array length and array in itself have exactly difference of one value. So let's say there is an array length of 7, but the numbering of array starts from 0 to 6. So there are 7 elements. So therefore length is 7, but there are only 6, uh, numbering of the array. 0 to 6 becomes 7. Doing one by one, yeah, creates error. I did created some. Now for prevents that error. Now it prevents infinite loop caused by forgotten increment. Yeah, as I've said, if we forget to increment our index mutation or iterator, we get stuck into infinite loop. That can be quite frustrating too. It might even crash you, like your PC is using mostly, let's say, 50% or 99% of your computer, and you start a while loop. That's terrible. Now, last is move or borrows explicitly. So what for does is move or borrow explicitly. I don't know how it does. Now loop confusion. You ask loop is also a type. It says no. It's a keyword. Shit. तो वही तो हुआ ना same चीज. Loop is also something like forever loop. It's a loop. It's infinite. Whereas while has a condition and for runs on item in iterable and a return value. So loop is control flow construct, not a type. Well, I don't know the difference. Pardon me. Code prediction. Let's move on. Now code prediction. First code is output. I'll say 5 if the condition is true. But if we write this like if we write this in Python, if true, then do this and else do that. But we didn't mention whether what was true. What will it print here? This is this sounds stupid right now. So output is 5. This is correct because I guessed it that it automatically should have been true. That's why this statement exists. Because sometimes where we try to shorten it in JavaScript or Python, we assume it's true and we run it. And if it's not true, it mentioned explicitly. So it gets an else value also. So I guess output is 5, which is correct. Now condition is literal true. No loop here. It's just an if statement. Yeah, you can see that. Our second code was let x is equals to if true, then this. This becomes a statement, so it will return a void or that bracket value. So it can compile, I guess. Bracket is a value, not void like C. So bracket is a value in itself. So it has a value return to it. So it can combine, I guess, because it's telling me I am incorrect. You said it won't compile. I thought that, but let's analyze. So branch one is 5. Yeah, this is the branch one. This is branch two. And semicolon evaluates this to the value of bracket. So we are getting not 5, but a value of bracket, which is a explicit value in Rust, I guess. And then branch 2 is 10. Now evaluating I32 types mismatch. So this and I32 means 10 mismatch. So compiler throws an error. So what I said, I guess, okay, so okay. So it's telling me that compiler shows error. It will fail due to type mismatch, but not because single semicolon alone is illegal. Semicolon wasn't illegal. It was just that the I32 and this type uh, was not compatible. So there are many questions right now, but let me ask this one only. So between these two, the type of I32 means integer of 32 bits. But what does this bracket alone means? This means its type or whatever. Right. Now we know that this will fail, but not because of single semicolon. It will because the return value of after semicolon this default return value and I32 are not compatible, so they are incompatible types, which makes the compilation fail. Now ownership in a loop. As I said, we took directly the v that was vector and changed the ownership and then trying to print it throws error. This is correct. So what I said was this x is now assigned the pointer value of v and the v became invalid. That's what I said and it's telling me I was correct. Now this calls the into iter which moves v after that v is invalid. So to fix Yeah, to fix that, we take just the reference of v. We do not take the whole variable v. We just take the reference of v. Or we can just uh, use function of a class, I guess. I don't know if it's a function of class, library, standard library. I have no idea. But we can use iter. It will, I guess, iterate over the values of vector. So we are taking the values of vector, but not just by the reference. We are taking it through a function that will handle it for it. Now again, back to my question. It's asking me too many questions here. What is ampersand static Oh, this is my question. Okay, I asked it. So what is ampersand, single quote static stuff? This is critical. We go from first principle. What is this thing? Break into its part. So stir means primitive string slice type, which is unsized, always used behind reference. You have never written this statement. Yeah, you write ampersand str. Ampersand str, a string slice two things, pointer to UTF 8 bytes length. It does not own memory. All right. Yeah, ampersand does two things, which is a pointer to a UTF 8 bytes and then the length of it. And if there is capacity, then capacity. It does not own the memory. All right. But this static, this is a lifetime. It means data lives for entire duration of the program. Oh, so this becomes for a life, whereas this becomes just for the scope. Scope ends, it ends, you forget the pointer, finished. But this gets to live for the lifetime of the program. So for the duration of the program running, this thing will live its life. A string literals is like hello are stored in program's binary. They live forever. So their type is this type. So this is again a new type that I got to know. I guess it's interesting because it lives on forever. It does not depend on anything except the runtime or the lifetime of the program. Now, why your function uses it? Why does my function uses it? You told me to. I had no idea I should use that. Because you return string literals like negative, positive, or zero. Yeah, that's what I do. So all those are static. All of those are static. They are not going to change. That's right. So return type must reflect that they are static and not going to change. All right. Important contrast. Now this is S, which is this is just trying to string, and from we are taking hello and storing it in S. That's what it's doing. So type is string. This is owned by S. Heap has been allocated to it. Yeah, pointer. Now this, what is this? This is a statement. This is a type of ampersand static stir. So this becomes static. I guess then this cannot be changed. This can borrowed. Can static stir become mutable? As the name suggests, it shouldn't. SHO U, correct? SHO UND. It shouldn't. Mhm. Sure. A valid question that after I assign this as this string hello, can we change it later on to sort of hello world? Now it's trying to ask me again. So let's see what it's asking me. So it's asking me why can a function safely return ampersand static stir but not return ampersand stir, referencing a local string. Oh, but not return ampersand star, referencing a local string. I guess I know the answer. I guess BCAUSE because ampersand static stir lives for the lifetime of the program and at the end automatically gets filled somehow. So for the whole program, it should remain valid. Now, whereas taking reference of str. You know, variable is variable. Reference of s or reference of str, which is immutable. Returning them becomes useless as they are just the reference of another variable str. We can just take the value from it. I guess when we return something, we need its value to be assigned to something. But when its value is already assigned, like ampersand star is already assigned a value which is immutable, which cannot be changed. So why should we return it to something else, then store it in something else, then use it? Why not just directly take the reference again if we want to use it? And there are multiple spelling mistakes that arise. That's why I said do not vary. Is muted. Oh, ChatGPT will try to understand. Yeah, it will. It is a natural language processing, whatever it is. Now, second question. What is the second question? What is difference is memory location between string and literal? I don't know. String and literal. What is literal? Literal is also string. But I guess the lifetime remains static. Literal. What is the difference in memory location between string and literal? I don't know. I guess that string memory location, memory location is just a pointer value saved to another variable, and we access the string to it as for literals. I don't know what you mean. Now, what is size of ampersand star in memory conceptually? इसका भी I guess it's 8 byte. I guess that it's 8 byte in size in memory. I just guessed it. I've read it somewhere here only. Alright, now mini code prediction again. Does this compile? Why and why not? Now this is a function called bad. It has a return value of ampersand star, which is immutable star reference. All right. This is returning ampersand s. So this is returning hello. Does this compile? Why not? I am assuming from the name of function bad, it shouldn't compile, but I don't know the reason. Why it should compile? Uh, what it's trying to do is, let's say there is a, no, not let's say, there exists a variable called s, which has a pointer value string, let's say. it has a string of hello, and we are trying to return that using ampersand s. But is it out of scope, or is it something else? Is it something we are missing out on? I am guessing that it is trying to return the value. It's not, oh, sorry, sorry, sorry. It's not returning the value. It's returning the reference, ref, reference, reference value of the S outside which I guess is out of scope. So it could not be possible. Does this compile? So not compile. Yeah, answer precisely. We do not move to loops. Oh, we actually did move to loops. We started from loops. We know there exists a loop which runs forever, which is like forever loop. Then there exists while and there is for. That's what you said. But all right. Good. You're thinking the correct direction. Oh, oh, very good. What is this bracket? You asked, what does this mean? And its type. This is a unit type. Oh, I wanted to know its name so many times. I'm just calling it either a bracket or just this. I never knew its name. Now we know this bracket, which has a value in Rust, is called the unit type. Unit, I guess it's just a unit that gets returned by default. So that's why unit type. Great name, I guess. And it is a real type in Rust and exactly has one possible value, that is a unit type. Represents no meaningful value because it is only unit type. You'll remember its name by calling it unit type, type again, again. So there is a variable x which is assigning the unit type value unit type to itself, like x is assigning the unit type value. See, why is there two? Because if there is anything called X and it is not doing anything, it will automatically, I guess, by default return this. So we are saying no, don't return it, but also take the value of unit type and put it inside. So you are unit type in itself, but that's by default. We know that. So we are taking a unit type and putting that in another unit type that's by default and returning that to X as a variable. I don't know why we have to do this. Now, why does it exist? Why does it exist? I don't know. Why does it exist? So it's telling me because Rust is expression based. Oh, Rust is expression based. Every expression must return a type. All right. If something returns nothing, it actually returns this. So it is telling me everything has to return something. So if there was some function that were not returning anything, it has to return this, but by default, because Rust is expression based. A comparison with C, void has no type. This unit type, actually a type which is called unit type. This is stronger, more consistent in type theories. All right. Now, can this single quote and static stir become mutable? You asked, can static stir become mutable? No, because it is static. You know? The string literals like, acha, so this is called literal. I guess so. String literal like s is equals to hello are stored in read-only memory, embedded in binary, and it is immutable. You cannot modify them. This is illegal. Uh, this thing is illegal. We cannot do this operation on this. But if there was let mute s is equals to then string from hello, and we were storing it like that, then we could just because it was mutable then we could just push a string or just push a character to it, and it would be a mutable and it would be perfectly legal because I did that yesterday. Now, because ampersand str does not own the memory, the pointer string does not own the memory. What it does, it has no mutation method. Because str does not own the memory, it has no mutation method. Ampersand str does not own the memory, it has no mutation method. Literal memory is read only. So this does not own a memory, so it has no mutation method. Yeah, because it is immutable. Ampersand str is immutable, but if there was ampersand mute str, then it would not have been this bad. Now literal memory is read only. Literal memory is read only for this, yes. Now your lifetime explanation is correct. You said that ampersand single quote static stir live for a lifetime of the program and at the end automatically gets freed somehow. Not exactly. This is not correct. So string literals are embedded in programs binary. Yeah. Loaded into read-only memories and never freed manually. Exist for entire program duration. So static means valid for entire program execution. And after that, it automatically becomes a garbage value. So no need to return or free it. It exists for the program and it gets loaded into read-only memory. Means it gets loaded into RAM, first of all, the whole value, and never freed manually. Now valid for entire program execution. Now I said that returning ampersand star, which is immutable, becomes useless. Incorrect reasoning. Oh, it might be useful. It's useless for me right now. Now incorrect reasoning. The issue is not immutability. Immutability. The issue is ownership and lifetime. For a lifetime, it can only remain the same. Now, why bad does not compile? Your reasoning is returning reference outside its scope. Oh, this is correct. I just guessed it. So now let's break it precisely. Now there is function bad, which has a return type of str, which is immutable str, reference of immutable str. So this is also a reference of immutable s, which is a variable s here, and this is the scope of it. Outside the scope, it is no longer valid. So why are we returning its reference to outside? It is not valid. So what happens is as S owns the heap memory, then S is dropped at the end of the function. Yeah, here S is dropped. And as we return this ampersand S, which is the reference of the destroyed data, this creates dangling reference. Like this reference does not do anything because it is invalid. S has already been dropped. So what is trying to point towards? No one knows. Rust prevent this at compile time. So this is the real reason, not immutability, not because it's useless, because memory would be invalid. Yeah. Now memory location difference. You said string memory location is just a pointer saved. Half correct. Let's clarify it. Now string, that is just simply it's a s variable which has a string value of hello stored to it. Now it is a stack, has a pointer, length and capacity. Now in heap, it actually becomes UTF-8 byte. When dropped, heap memory is freed. So memory location ka difference, I asked it. So string memory location is just pointer saved. It is half correct because it's not just pointer, it's pointer, length and capacity in stack, and the actual becomes 8 bytes in UTF in heap. And when dropped, heap memory gets freed. Uh, When this S gets dropped, like out of scope or something else, it becomes already heap memory freed. Now, string literals. What is this? Okay, string literal, like the same thing. Ampersand, a single quote, string str. That's what it meant. So this will stay for the lifetime. No capacity needed, I guess. So in stack, this is just a pointer and has a length. In binary, it becomes a static read-only memory. So no heap allocation. So therefore, no free. Oh, so no heap is allocated to it. So there is no need to free it. Now, what is the size of ampersand stir? I said 8 bytes, not fully correct. On a 64-bit system, ampersand stir is 16 bytes. All right, so 32, it's 8. And because it's a fat pointer, like 8 bytes stores the pointer and 8 bytes stores the length. Good. So structure is something like this. Ampersand stir, uh, and it has a pointer, constant u8, and it has a length. U size is uh, unit size, I guess. Now the total is 16 bytes on 64-bit. Now I'll test your understanding properly. Why does string needs heap allocation but hello does not? All right. String needs heap allocation. String needs heap allocation because it is uh, trying to store pointer, then length and opacity in stack. So in heap, it gets assigned ASSIGNED, assigned a memory, whereas this hello, which I guess is the literal of time ampersand single quote string stir, it gets converted to binary and remains for program lifetime. So no key allocation. I guess this is the answer it needs. This was the first. There is second question. What does the second question says? What it says is, what exactly is dropped when a string goes out of scope? When a string goes out of scope, it drops the pointer. It drops the value of the pointer. It drops the pointer. Stop. It drops the memory where the pointer length and depth of existing. So it becomes invalid when goes out of scope. A third question is like why is returning ampersand single quote static stir is safe, but returning ampersand string from local variable is unsafe. Let's think about it for a second. What we can say is, see, this is static star, so this is also immutable. We do not want to change it because it gets compiled to binary. So yeah, never gets changed. What I can say is that percent static star gets converted into binary in read only format, whereas the ampersand string is borrowed, yeah, referenced. Uh, uh, it is a borrowed or referenced, you know, pointer value, and if due to some re RESO REASON's reason that gets dropped, it becomes invalid. So we should use ampersand static stir instead of immutable string. Immutable string to be safe. Now, third question has been answered according to my understanding. Can answer according to your own. And now, fourth question is this unit type? Yeah, this bracket, I'll call it unit type from now on. So, is unit type stored in memory? Do we need to store unit type in a memory? Do we need to? If yes, how many possible values does it have? This is called a unit type, which I guess is just only, and it is the default return value of everything that returns nothing. So yes, in language itself, it has a value called unit type. Now there's a code prediction. Let's do that. Fifth one is correct. Fifth, damn it. Fifth one is code prediction. Does this compile? Oh, okay. So it should compile. But let's see what it does. OK is a function that returns a static literal. So let's write it down. So I can see that OK is a function that returns static literal literal that gets converted into binary and remains for the in entirety of the program's life. So yes, this should compile. Now there is another one. Also, does this also compile? So it is also a bad. So from this function name, I can say it will not compile, but I need to give a reason, explain precisely why. So also bad returns ampersand string, and ampersand string is returning the value ampersand s. So yeah, it is returning the value that will become invalid after the scope. So no. Here I yeah. जल्दी कर दो क्या हुआ कुछ नहीं के कॉल कर रहे हैं मैं पढ़ रहा हूँ हाँ, so I guess we have thought enough. So let's just write it down. SHOULD should compile. I can see that also. Sorry, that oh my keyboard is like old, very old. So it gets jammed and I don't know what not. Oh, I can see that also not so. Also bad function has a return type return type of you know reference value, but the variable s will be propped when the scope ends, so it will become invalid. And in this function we are returning the invalid flag, which will stop our Rust C from from compiling it. It's not like C. C would have just compiled it, all right, but Rust will not. That's why Rust is safer, far safer than C or C++. But it might also have some downsides that we don't know much about. It's a not fairly recent language, but still, it is quite new compared to C. I got the answer. So, why does string need heap allocation? That was a question. Now, I said that string needs heap allocation because it is trying to store pointers, length, capacity in stack. Not correct. This is cause effect. The reason is not because it stores pointer, length, and cap. The real reason is string is growable. But this is immutable string, so it shouldn't be growable. Oh, string is growable. So yeah, I think what we can do, why it is saying string is growable. Let's say it's an immutable string, and we take the value from immutable string and put it in a mutable string. Now it will grow. But still, yeah, this does not explain why string is stored. Now string is stored because string is growable. Its size is not known at compile time. All right. Let's take it. Let's just take this uh, as it says that string is growable because its size is not known at compile time. Example is there is mutable string s which has a value high. Now we are pushing the stir there and it becomes high there. So the compiler cannot know the final size. Yeah. So stat is a fixed size which is at compile time, which is known, but heap has a dynamic size because runtime it gets allocated. Thus, string uses heap. Why hello does not? Because size known at compile time. Size is known at compile time, stored in binary, read-only section, and never changes. This is a static string. The ampersand, single quotation, static, and str. This is hello. This is also called, I guess, string literals. So no dynamic allocation is required. What gets dropped when string goes out of the scope? So what gets dropped when string goes? I guess pointer. It drops the memory where pointer, length, and cap existed. Not correct. All right. Stack memory disappears automatically. What is explicitly dropped is the heap allocation, the UTF-8 buffer. Oh, here I was talking about stack memory, but stack memory is at compile time. So at the runtime, it should be heap allocation. So heap allocation is dropped, which is UTF-8 bit buffer. So it drops the process string destructor then runs and heap buffer is then deallocated and stack metadata disappears naturally. So important distinction is that key heap allocation at runtime and stack memory at compile time. So this is what compile time looks like. But at runtime, heap is allocated 8-bit buffer and so on so on. Why returning ampersand static string is safe? You said we should use ampersand string instead of ampersand string to be safer. This is dangerous using. Oh, I became dangerous already. So we do not need static to be safer. We use static only when data truly lives for entire program. The real rule is that returning reference is safe only if referenced data outlives the caller. Now static guarantees that. Returning static from variable is unsafe because local variable is dropped and reference would just dangle. Let's try that again. We do not use static to be safer. Use static only when data truly lives for entire program. All right. All right. We can be safer by using immutable or mutable also. But we use static when we know truly that it will live for the entire program. The real rule here is that returning reference is safe only if reference data outlives the caller. Yes, as we have seen in two earlier programs, the same program, just two times. Now, static guarantees that it will outlive the caller, whereas just this is just a reference, so it may not outlive the caller. It may get destroyed or get out of reference. What is that? Out of brackets. Uh, I knew the word, yeah. I just forget. Inside the bracket, this is called you know this. What is this? Inside the bracket. Uh, scope. Yeah, scope. So if the borrowing that we are taking from some variable, if it gets out of scope, it may get dropped, and then this becomes unsafe. From local variable is unsafe because local variable is dropped at any point of time if we do something wrong, and reference would then dangle around and would be useless. Now, unit type clarification. You said it has value called unit type. Better phrase is this is a type in itself. This is unit and this is a type. It exactly has one value, that is this value. It represents no meaningful value. It absolutely exists in memory model, but since it has no field, its size is 0 byte. Yes, zero sized type. How ridiculous. Amazing, but ridiculous, but still amazing. It is a type that has zero size. My God. But still has a value, and the value is bracket itself. And the bracket is the name itself. The bracket is unit type because it is a type, and bracket is also its value. Damn frustrating. Fifth thing, your function analyze, like there was a OK function and it was returning the static literal. So yeah, my answer is correct that it compiles because hello lives for entire program. It is a static. You know, it lives entire for the entire program. So callee can get this reference. Caller. Caller can get the callee. Oh my. Now, this also bad was also a function. The correct reasoning is S is dropped, and so I did the correct reasoning. Compiler prevents it. Now sharpen you further. Okay, teach me something. Finally, you still have one misconception. Damn it. I still have one misconception. That is, I think that ampersand string is unsafe. It is not. It is just immutable. And if it gets out of scope, it becomes dangling and it becomes unsafe. But let's see what you are trying to say to me. It is saying it is not unsafe. It is unsafe only. See, that's what I'm trying to say. If owner does not live long enough, and we are human, we do some stupid mistakes. We may take some owner out of scope and then just leave it there. And our program, the Rust, so-called Rust, will not no longer be safer. No, it will be safer because it will catch it at compile time, but still, human error. Example, this is safe. Like, yeah, I know this is safe because it is taking a ampersand string that is a reference outside of this function. This is the function, and we'll write it in like main. We'll assign it a value from the main has some variable, let's say string one, and we'll pass that value through good as a function, and then we'll do some operation on it. Yeah, this is safe, obviously, because the variable string one does not dies. It does not go out of scope most of the times. But let's say if I did not, instead of doing that, I just made a variable here only and referenced it outside the scope. It would become dangerous. Simple as that. Because caller owns the string. Yeah, I know. Function only borrows it. Safer depends on lifetime relationship, not type names. All right. So if it lives long enough to see the caller, voila, it will work. If it does not, damn it, it's gone. Now we have dialing pointers out of nowhere. And now final lifetime test is answer precisely. All right, I will. You're not teaching me anything. I'll answer precisely. I will answer precisely. A conceptual question. What is difference between ampersand string and ampersand str? There shouldn't be any difference between these two in terms of memory layout and ownership. They are the same. Why str called a slice? I've never heard it. Tell me. Or do I know something about capital string? Capital string. Ah, this capital string is, I guess, a type, whereas the this str is a ref is a name and immutable reference of str. See, I know this. I guess I know this. It might say you are wrong again. Well, good enough. My reasoning is good enough for me, I guess. Now, why is ampersand str called a slice? I don't know. I don't know. I don't know. Ampersand str. You didn't told me, so I don't know. Or a slice because I'll write whatever I know. It's it's chat GPT's, you know, I don't know, it's stuck there. It's not teaching me anything. Yesterday, it taught me something very important. I was going with the flow. I was learning enough concepts, and now it's just looping in the same thing. But yeah, I'm learning something. PCAUS. I don't know. Ampersand string is called slice because it takes the reference to str variable. So slice or bar. I just guessed it, and it's probably just wrong. So what? I'm overconfident. And ChatGPT is just some word throwing machine which is trained on damn too many datas. So if I write let s is equals to string from hello and then r is equals to ampersand s, where is the string structure stored? Simple, very simple. In this example, we are assigning ASSIG NING the heap pointer to the variable s. What we good is immutable variable s. By default, it's immutable. You have to write mute to make it immutable. That's what I know. from yesterday lecture, but now it's not teaching. And R gets a reference of the variable S by n% S. So S remains the owner, and R becomes a borrower. Is it good enough? I guess so. REFERE, stored in key memory with pointer s. Natural character stored. And so is this static a storage location for life or a lifetime annotation? This static static signifies a lifetime annotation. It gets stored, Steve, oh, Steve, store in binary read only format. Code reasoning. Does this compile? I guess, I hope so. Now there is a function called choose. It is taking three things. First, variable a, which is a static literal, I guess. Variable b, which is again static literal, whereas flag, which is a boolean, true or false. And then it is returning a static string, not static string, but static variable. The return type is static variable. All right. So the return value of this choose will also remain in binary. As for the, the input in the choose of a and b will also remain in binary. As for the flag bool, how it works, we don't know about. If flag a like is true, if flag, so if true, then a, else false. Flag is the condition here. So if flag, which is boolean, is true, then a will happen, else b will happen. And a is a static literal. A, b, and the return value of choose function function is a static literal or type, you know, ampersand this ampersand single quote static str. root, it becomes the candidate. So it says if root, then a return. If not, then b. Yes, yes. So it compiles. Compiles. It compiles. All right. Is there any sixth question? Oh, there is no sixth. Thank God. Thank God. Tell me everything. Tell me, please, please. Tell me. Oh, I am improving. Thank you. Thank you, sir. I am improving. But your answer are still imprecise. With this answer are still imprecise in important places. We refine now. We are still refining just these three things for I don't know how many hours long. You wrote ampersand static is type, whereas ampersand str is immutable reference of structure. Uh, str, which is a variable. This is vague and partially correct. Let's be exact. So memory layout is string, which is structure on stack, has a pointer of 8 byte, length of 8 byte, which becomes 16, and then capacity of 8 byte, which becomes 8 3s are 24. So it becomes a 24 byte on 64-bit machine. Heap is actually UTF-8 bytes. Now ampersand string is like pointer to these things. This is a reference to 24 byte string structure, size 8 byte, just a pointer to stack structure. It does not point directly to the characters, it points to the string structure, that. Uh, and ampersand str, this is a slides. It contains pointers and length. That's it. That's it. Total of 16 byte. It points directly towards UTF-8 data. It does not know about its capacity or whatever. So key difference is type of string, owns the data, yes. Points to heap, size is 24 bytes. Now ampersand string, which is pointing towards this string. So does it own the data? No, string does. It's just pointing towards it. Points to string, it's pointing towards this. And it has the size of 8 bytes because it is storing only the pointers. I guess so. Yeah. Only the pointers are being stored. So therefore 8 bytes. Whereas ampersand str, does it own the data? No, string does. Sorry, it points to UTF-8, which is, I guess, the UTF-8 is a heap. So it points to the heap, which is of size 16 byte because it only has capacity and pointer. This is a critical difference. Why is str called slice? You said because it takes reference to the str variable. Incorrect reasoning. It is called slice because it represents a view in contiguous sequence of bytes. Continuous, contiguous sequence of bytes. Example is like string, and we have value hello world in that s, and slice. Let's say we are slicing it 0 to 5. Now slice is what it does. I have never tried it. Let's try compiling it some other time. Now ampersand str. So remember to just put it in a main function and try compiling that main function. Let's see what we get. And yeah, try printing that slice, value of slice. Print ln macro, boolean macro. Now the slice is s ampersand str pointing to the first 5 bytes only. First 5 bytes of hello world. HELLO. 5 bytes, I guess, is finished in hello. So it does not own it. It views part of something if mentioned. This is slicing. So therefore ampersand str, which is pointing towards you know the value stored of a string, it does or can be used to slice the data, read from it. That's why it's called slice, I guess. This is slicing. Memory location. Your answer correction. I wrote that reference and actual character stored in heap memory with pointer s, not precise. Correct answer would be that s is string from which has a value of hello, and r is ampersand s, which is pointing towards s. So where things are like s is 24 byte structure, all right, stored on a stack, runtime, then heap contains the hello, yeah, on the no, sorry, on stored on a stack at compile time, then heap contains hello at runtime, then r stored on stack, r stored on stack, then r points to s, not directly to the heap. All right, all right, all right. Yeah, if r would be just pointing towards the heap, it would have become the owner, but it is not. It is pointing towards s. S is the owner. So if R wants to read the heap, it will go through, it will point to S, and then S will take that pointer to heap. There's two levels in that. Good. Now this static meaning, you wrote it gets stored in binary read-only format. Yeah, not fully correct. Static is not storage. Yeah, I said that it's not a storage. It is a lifetime annotation. That's what I said. It's not even considering my answer. See, static signifies a lifetime annotation. Spelling mistake, but still, it gets stored in a binary read format only. Yeah, it gets stored somewhere. It is not storing it. It gets stored somewhere for the lifetime of the program. Now, static is not storage. I know that. It is a lifetime annotation. It means reference data is guaranteed to live for entire duration of the program. Yeah. String literals happen to live in read-only binary memory, but static itself is not storage. String literal happens to live in read-only binary memory, but static itself is not storage. It is lifetime constraint. Very important distinction. Now it's telling me choose function. Yeah, there was a choose function. I did the correct reasoning. It compiles because both input are this static literal and return value is one of them. So life is preserved. Lifetime is preserved. So this is correct. Now we final check before moving to loop. Oh, it's asking me a question again. Very good. We are not reaching the loop till now. Conceptual question. Why is ampersand str, which is 16 byte, but ampersand string only 8 byte? 8 byte. Let me answer that very precisely using very few words. So, yeah, it's getting right. So, ampersand string points to string string. So it only stores, so comma, so ampersand string only stores the POI pointer value that is 8 byte. But uh, ampersand str, it points to the to the heap, I guess. Did I forget it already? Ampersand str points to the heap. has only pointers and pointer and one pointer and cap capacity or length. Pointer and GTH both of 8 byte TOTALLI both linked to 16 byte. Is that good enough? I guess so. So now question two. Question one is this. Question two is this. Why conversion is implicit and ampersand string points to ampersand str? Why conversion is implicit? Which conversion is implicit and why? Does does Rust allow it? Why? Now this ampersand string. I don't know. Let's take a guess. Ampersand string is implicit. You will see because it internally points towards the structure string. Yes, the Rust allows it. If I write let s is equals to string from hello and then r which is represent str gets a value assigned. What exactly happened under the hood? I never did this. Can I see what it already said? Ah, so what was the data? No, points to UTF-8. UTF-8 is 16 bytes. Wow. Ampersand string was the data? No, points to string, which is 8 byte. String points to heap. There's nothing related to this. What happens here? I'm seeing this expression for the first time. This thing. So I don't know what that means. You have never told me what that means. So please tell me before asking the question. Tell the concept first, then the answer. Why is this valid? So we have a string and then we are slicing it. Uh, we have a string value hello string hello stored in a variable s, then we are taking the reference reference ampersand s and s slicing it, by doing this and store storing that in variable r. Is that good enough? Now it's telling me answer. Oh, it's done. Be refined, then I explain the missing concept properly. Why ampersand str is 16 byte but ampersand string? Your answer, ampersand string only stores pointer value which is 8 byte, ampersand str pointers and length totaling 16 byte. That's what it does. That's what it does. Yeah, that's what it does. Yeah. So yeah, why at ampersand is small str is 16 byte. Correct. Now, for formal reasoning is ampersand string is thin pointer points to stacked structure, which just takes 8 bytes, whereas ampersand str is a fat pointer, needs pointers to UTF pointers to UTF 8 bytes, then length of slice, which totals to the 16 byte total. So now important principle. Slices are dynamically sized types. So DST, again, a new type. DST, dynamically sized type. Then there would be a static size type. Yeah, there is. What is this ampersand, single quote static? It is the same. Static sized type. And now slices are dynamically sized type. All right, thank you for telling me. Therefore, reference to them must carry metadata, that is length. Yeah, so I got your point that str is taking two things. First, pointer to the UTF-8 byte, and then the length of slice, which totals to the 16 byte in total, because length is also 8 byte. So yes. And second question is ampersand string string and str implicit? You answered vaguely. Now I teach the concept properly. So there is derivative coercion, important concept. You have never told me derivative coercion. What is this? Now Rust performs something called derivative coercion. Static implements, string implements. So this is something like implies derivative for string type target is equals to still, meaning a string can be dereferenced to str. Oh. So the string that we were storing for now, all these minutes were like pointers, length, and capacity. can be now dereferenced to str directly. So when you write let s is equals to string from hello and let str is equals to ampersand s, Rust does this ampersand s, which points to ampersand string, which points to string. It's dereferenced to ampersand str automatically. This is implicit coercion. So string to ampersand str is allowed because of derif trait. Now what happens under the hood here is that this string, step by step, s lives on the stack, then s contains the pointer, uh, s contains the pointer to heap. Yes, s does contain pointers to the heap, and that's it. That is why it is 8 byte, isn't it? It is 8 byte. Ampersand s creates ampersand string, that is thin pointer, 8 bytes. Rust applies direct coercion, converts string into ampersand str. Now R stores the pointer to heap byte and length. So R stores it directly to the heap. It does not point to the stack structure. It becomes slice pointer. What does this means? You said slicing it. Close. Correct explanation. This means take entire range of s equivalent to ampersand s 0 to s dot length, and it implicitly produces a ampersand str slice. So string implicitly gets converted into ampersand str by slicing it. What's the use of slicing it? Why are we slicing it? What's the use of slicing it? Why are we slicing it to ampersand str? And let's say we have a immutable variable called str, and then we take its reference like ampersand str. Are they both ampersand str the same or different? I think it's different. What about you? What do you think about it? I test your understanding properly. Why str itself unsized, but ampersand str is sized? See, it never told me that. Ampersand str is sized, it's unsized. I have to take some reference. Ampersand str is sized because it's totaling to 16 bytes. Then str is unsized. What does that mean? As said, explain it in depth before asking an question. I just started to learn Rust. Yes, the day I am very happy Yeah, yeah, barely a beginner. Well, that means I must institute. Yeah, you did not introduce dynamically. This is day two before properly testing. You slow down, no gaps. Why is str unsized but ampersand str sized? We go from first principle. What does sized means? In Rust, a type is a sized if compiler knows its size at compile time. Example, I32 is 4 bytes, U64 is 8 bytes, Boolean is 1 byte, string is 24 byte on 64 bit, and ampersand string is only 8 byte, all known at compile time. Why str is unsized? What is str? It represents sequence of UTF-8 bytes. But how many bytes? Could be 5 in hello, 100, million. Compiler does not know the length of arbitrary str at compile time. Therefore, str is unsized time. You cannot write let s be str. It's illegal. All right. Because compiler cannot allocate space on stack because it does not know what str's size is because it is unsized. So you should give it a structure that is sized so that compiler can allocate the space on that stack. How does ampersand str works? Ampersand str is a pointer at length. Like, yeah, ampersand str has two things stored. That's why it's 16-bit. First is a pointer to the UTF-8 on the heap, and another one is length. Yeah. So the length is stored inside the reference. The length is stored inside the reference. The length is stored inside the reference. What does that mean? Let us think about it here. The length is stored inside the reference. And reference, what are the reference they are talking about? Ampersand str looks like a reference in itself, but it's referring to str, which is unsized. So I guess that's what they're talking about. So str is unsized, but as soon as we reference it using ampersand str, it gets a length. So the length is stored inside the reference. We are referencing the str using ampersand str, and we are storing the length inside the reference itself. So even though the data size varies, like str varies, but the reference size is fixed on 64-bit. Oh, that's interesting. So now I know what ampersand str meant all this time. What ampersand str is, now I know. Ampersand str is just a pointer pointing towards str. It's pointing towards this. But we know that this is unsized. This has no size. But to allocate some memory in heap, we need a size defined. That how much? 100, 1 million, 1000. How much memory do you need? So when we are pointing towards this str using ampersand str, we are providing it with the length, that this is the length, and the length gets stored in the reference itself. The length is stored inside the reference. Well, quite nice. So even though the data size varies, the reference size is fixed. The data size, how data size varies because str is unsized, so it has no size. So it may vary according to different references, but the reference size is fixed. So when we allocate it to a reference size, it gets allocated. It does not throw an error. So on 64-bit machine, we get a 16 bytes of total reference towards str. Now the compiler knows the size of the reference, so str, which was unsized, and the reference to it, which was sized, so it gets compiled. Think of it like this: that str is like saying some text of unknown length. Whereas ampersand str, which is referencing the str, is saying text located here and here is its length. Nice. This is why slice reference are fat pointers. Why slice a string? You ask why the use of slicing it. Very important question. I never do. String own heap memory. So string owns the heap memory. Yeah, it does. Yeah, UTF-8. String owns the heap memory. It does not get converted to binary. And in runtime, you need to store it somewhere. It's in heap memory. Yeah. But sometimes you don't want the ownership. You just want a view into a part of it. Yeah, I totally agree. Like, let's say there is a text, and I know that the file name of the text is stored in the first line. So I will go through that first line only instead of just changing the ownership and creating a different file with the same data. I'll not do that. I'll just slice the first line from it. I'll read it and I'll know the file name. That's what it's doing here. That if I wanted to just know what this string is starting from, like the first character of it, H, we can do that. By what? By 0 to 1. Because 5 will not get included, I guess. I guess that 5 will not get included. And if you want to print the whole thing, we have to write, s dot length. वो len वाला function चलाना पड़ेगा. Now s still owns the data. Yeah, s does still own the data. Hello is just borrowed slice. Yeah, this hello was just borrowed here with the reference to the s, and it was stored in a variable called hello. Now the hello is just borrowed slice. No allocation, no copying. This is efficient. Now hello variable just points to a part of the reference of the whole s variable. The part is 0 to 5 in array. Nice. So we are not allocating different variable with different data. Like it's different data, but we are just referencing some data which owns that data, and we are slicing it using it. Why convert ampersand string into ampersand str? Why do we convert ampersand string to ampersand str? Because most APIs expect ampersand str, not ampersand string. Why? Because ampersand str is more general. It works for string literals, string slice, full strings. All right. So let's just get a print text. A function is print text. It takes variable called text, not just variable called text. It is taking a variable, and that is pointing, that is referencing from str, and then we are printing the text. Good enough. And we are not returning anything, so we are returning the unit type, the brackets. You can call now print text on hello and print text ampersand string from hello. That is flexible. So either we can directly write the value here, which is hello, or we can write the whole pointing thing here. This is well flexible. Important clarification is you asked if we have immutable variable called str and take ampersand str, are they the same? We must be precise. Case one, let s is equals to hello. Type is, yeah, static literal, so static str. Case two, we have a variable s and it has a string. Now it's immutable, but it's not static literal, and we are then taking the reference of s. The type of R is ampersand string, which is this. Its reference is stored in R. But because of tariff coercion, it can become ampersand str. This thing can become implicitly ampersand str, as we have seen earlier. We'll just write ampersand str, then colon, and this ampersand s. So they are not the same type, but they can behave similarly due to coercion. Now at test understanding gently, no advanced traps. Answer these clearly. Why can't Rust put str directly on the stack? What happens if Rust puts str directly on the stack? What will happen? Str is like unsized. So it has no length. So how much memory to allocate? It does not know. Let's answer it. Since str is unsized, the Rust doesn't doesn't know the length it will take in the scheme. So we can't put directly str on the stack. Stack. What exactly is stored in ampersand str? Ampersand str stores UTF-8 byte pointer and LENGTH of str. So I do not number two. Now three. Why is ampersand str more flexible in function parameters than ampersand string? Why is ampersand str more flexible in function parameters than ampersand string? Tell me why is it? Why it is? Why is ampersand str more flexible in function parameters than ampersand string? More flexible in function parameters than ampersand string. Because we can slice it, we can use the full string, we can do all sort of things with ampersand str. Fourth question is it valid and why? So we have s and string. It seems valid. It seems like it is valid. Why can't Rust put str directly on the stack? You said Rust doesn't know the length it will take in heap memory. Small correction. It is not about heap memory. It is a size at compile time. Yeah. Okay, stack. All right, stack. So stack memory requires the compiler to know how many bytes to reserve. Since str can be any length, its size is unknown at compile time. Therefore, the str which is unsized type, which is dynamically sized type, cannot live directly on the stack. Correct core idea would be that stack needs fixed size. str does not have a fixed size. What is stored inside ampersand str? You said UTF-8 byte pointer and length, which is correct. More formally, it is a pointer with constant U8, again a size, U8 as new size, I don't know about, and then U size. I know this about uniform size. On 64-bit, it totals to a 16-bit total. 8-bit, 8 byte each. 16 byte total. Now, why is ampersand str more flexible than ampersand string? You said we can slice ampersand str and get full string. That's not the key reason. The real reason is ampersand str is view of UTF-8 text. It works for string literals. It works for string literals. That is hello, full string, or part of the string, or substring slice. But ampersand string only works for borrowed strings specifically. Example is, let's say, print text, t ampersand string. This cannot accept hello, but let's say a print text, which is t ampersand str, can accept. All right. So this cannot accept this hello inside this, but this can. Hello ampersand string slice. Because of deref coercion and slicing. So the rule is use ampersand str in APIs unless you specifically need string. This is idiomatic Rust. All right. Is this valid? Yes, valid. Because hello is a static string. So it matches ampersand str. This, however, is invalid syntax. Correct would be this only. I've seen something like that above. What was that? Oh, I'm seeing it. Can accept because of direct coercion and slicing. So rule is use ampersand str in APIs unless you specifically need automatic Rust. Is this valid? Yes, this is valid because hello is ampersand static string. It matches ampersand str. This, however, is invalid. All right. Correct syntax is this only. All right. So final understanding check before moving on. Answer precisely. Conceptual question. Why does string implement deriv target is equals to str? Does str own memory? No, it doesn't. If I write s is equals to hello and t is equals to s, is this move or copy? Oh my god. I guess nothing. I don't know because it is a static string and static string lives for the lifetime of the program. And we are referencing, not referencing, we are directly assigning the value to the t. So it must just copy it. Why is ampersand str considered a view rather than an owner? Control flow implementation task. Behave as expression plus loops. evolve only after conceptual clarity. There is a conceptual clarity right now. Uh, yeah, plus blocks, slightly. I guess I'll move forward with this instead of just relying on ChatGPT. This seems more, structured, and we are doing stuff, we are building things. All right, I'll start going through that. This, however, is invalid syntax. Final understanding before check before moving on. So conceptual question: why does string implements tariff coercion? Target is equals to str. Does str own the memory? String impl- implements str so that it becomes flexible to operate on. क्या हुआ, चले जा अभी? अरे अभी चले जा. हाँ ठीक है. ऑपरेट ऑन string to implement string so that it becomes. हाँ बोल दिया है. तो खाओ यार. कभी कॉल आ रहा है, कभी बात हो रहा है, काम नहीं हो रहा है बस. String implements str so that it becomes flexible to operate on. String implements str so it becomes flexible to operate on. Right. Like slicing, slicing, slicing it. Yeah. Does ampersand str own the memory? Does it? No, it doesn't. Or it does. It does. Yeah. Ampersand str towards towards to BBM 8 pointer as the length for str to allocate the required memory to str. And this is my understanding. If I write let s is equals to hello and let t is equals to s, what I understand is that S is static str which which will live like of the program. Then it gets assigned to the variable t. I guess it must be to copy. Why ampersand str considered a view rather than owner? Owner is str. Ampersand str is just the reference or the view with its pointer and defined ENGDH and line. Good, we are close. But there are still why does string implements? You said you are flexible to operate on line. That is not poor reason. The real reason is string owns heap memory containing UTF-8 bytes. Most string operations logically operate on STR, a sequence of UTF-8 bytes, not on ownership container. String owns heap memory containing UTF-8 bytes. Real reason is that string owns the heap memory containing UTF-8 bytes. Most string operation logically operates on STR, sequence of UTF-8 bytes, not on ownership containers. By implement deref for string target, type target is equals to str. It's returning bracket unit types. So by implementing this, Rust allows ampersand str to be ampersand str automatically. This enables calling str method on string, passing ampersand string to function expecting stir and using slicing syntax. It is about viewing own text as borrowed text without copying. This is the deep reason. Why does str own the memory? You, you said str point towards the UTF-8 pointer and has length which helps to allocate memory. The incorrect final clause. str does not allocate memory, it does not own memory. It is only pointer length. It borrows the existing memory. Ownership is elsewhere, either in string or in static binary for literals. Is this a move or copy? So let s is equals to hello and let t is equals to s. You said it must be through copy. Correct. But let's explain properly. A type hello is a static stir. That is a reference. Reference implements copy. So t is equals to s, which copies the 16-byte pad pointer. No ownership transfer. No move. Who is the owner in this case? You said owner is stir and ampersand stir is the reference. Careful. str not an owner. Ownership depends on context. Like s is the owner here. Owner string. Case B s here. Program static memory str always just borrow view. Uh, Correct concept would be that ampersand str is not owning view into UTF-8 bytes. Final lifetime plus string mask 3. Check if you get right. You are not able to properly. small and consistent.